Hey guys, today we're going to be taking a look at two questions, which is relating to rationalizing the denominator and the equality of surdic expressions. So let's get into it. Now, with the first question, we're asked to find rational numbers a and b such that a plus b root 5 is equal to 1 over 2 plus root 5. Now, the way to do this is really you just need to rationalize the right side and get it in a form where you can compare the constant of the right side to a and the coefficient of root 5 to b, and you will get your values from there. So let's get into this question. The first line, let's just write out the question: a plus b root 5 is equal to 1 over 2 plus root 5. And like I said before, we can rationalize the right side. So what we're going to do is times it by a fraction where the denominator is going to be the conjugate. The conjugate, as you may recall, is simply this expression, but we flip the sign in the middle. So since this is a plus, we're going to be using a minus. So the denominator is 2 minus root 5. And we also need to multiply the top of this fraction by 2 minus root 5. Now, the next line, let's just multiply the top and bottom out. So the top is 1 times 2 minus root 5. This gives us 2 minus root 5. And the bottom is actually a difference of 2 squares. So I'll just write this out on the side. The difference of 2 squares, as you may recall, is a minus b, a plus b, and the expansion is a squared minus b squared. Now, in this case, the a corresponds to the 2, and the b corresponds to the root 5. Therefore, our denominator is the expansion of the difference of 2 squares, and this is going to be 2 squared, which is 4 minus root 5 all squared, which is equal to 5. So on the next line, let's simplify the denominator. 4 minus 5, that's equal to negative 1. And what I would suggest you do, this is what I always like to do, is when you've got a negative sign in the denominator, we'll just flip the signs in the numerator and get rid of that negative sign in the denominator. So the numerator is going to be negative 2 plus root 5. Now, we're at a stage where we can start to compare the left side and the right side. So the left side is a plus b root 5. Now, what is our kind of constant on the right side that we can compare with a? Well, on the right side, we've got a root 5 and a root 5. And then we've also got a negative 2, which doesn't have a root next to it. And we've got the letter a, which doesn't have a root next to it. So we're going to be comparing a with negative 2 and the b root 5 with root 5. So our a is equal to negative 2. And we've also got the b root 5, which we can compare with root 5. Now, b is the coefficient of root 5. And on the right side, the coefficient of root 5, well, there's no number there, so that just implies it's a 1. So therefore, our b is equal to 1. And there you have it. Our final answer is a is equal to negative 2 and b is equal to 1. And those are both rational numbers which satisfy the question. All right, let's get on to the next question. Okay, so for this question, given that 6 plus root x minus y is equal to x plus y plus 3 root 2, we need to form a pair of simultaneous equations and then solve for x and y, given that they're rational. So how can we get the form, or how can we get a pair of simultaneous equations from this? Let's write down the question and work based on that. So the right side is x plus y plus 3 root 2. Okay, so how do we get the pair of simultaneous equations? Well, again, this comes back to something we looked at before where we compare the terms with a square root in them and the terms which don't. So in this case, the terms which don't have a square root, the left side has a 6 and the right side an x plus y. And then we've got this root x minus y and this 3 root 2 on the right side. So let's first look at the terms that don't have a square root. That is telling us that we can have an equation which is 6 is equal to x plus y. The other equation that we can write down is that x minus y, the square root, is equal to 3 root 2. Now, the above equation which we just wrote, 6 equals x plus y, is nice and simple. It's your normal or your regular linear equation. But here we've got the square root, and that's not too easy to work with. So let's get it in a form that doesn't have a square root. We can do that by squaring both sides. So the left side is all to the power of 2, and we need to do that to the right side. The left side, the square root and the square cancel, so we've got an x minus y. And the right side, when you apply the square to it, you'll have 3 squared times 2, which is equal to 9 times 2, which is 18, and the left side is x minus y. So this is our equation 2, and the above equation which we first found is equation 1. Let's work with these over here. So we've got 6 equals x plus y, and we've also got 18 is equal to x minus y. Now, solving these simultaneously, let's subtract equation 1 from equation 2. I think that's easier. So that means we'll have 18 minus 6, which is 12, x minus x, which is 0, and negative y minus y is negative 2y. Solving this, we get y is equal to negative 6. So that's our first value of y. We need to now find x using this. So substituting y equals negative 6 into, let's do equation 1. We will get 6 is equal to x plus y, but y is equal to negative 6, so x minus 6. And that tells us that x equals 12. And there you have it, our equations of x and y. X equals 12, and y is equal to negative 6. Thanks for watching, guys. Hope you learned something. Okay, here's page 2, and here's page 3.